In this video, I introduce world models. World models encode the world dynamics as the latent representations and then generate world future states in the latent space. The agent uses the memory and current state to find the optimal policy, which is applied to the physical world and interacts with the real environment to maximize the expected cumulative reward. Here is a model flow diagram. This is the observation. This is the vision model. This is a memory model. This is a controller C. This is output action A. The agent uses the vision sensory component to compress what it sees into a small representative code, and has a memory component to make predictions about future codes based on historical information. The agent uses the decision-making component to decide what action to make based only on the representations created by his vision and memory components, as shown here. The environment provides the agent with a high-dimensional input observation at each time step. The V model learns abstract compressed representation of each observed input frame. For example, a variational autoencoder is used as a V mode to compress each image frame into a latent vector Z, as shown here. This original observation frame, this reconstruction, and this latent vector Z. Since the environments are stochastic in nature, the RNN models the conditional probability of a future z t plus 1 vector, namely, it's a conditional probability. Where AT is the action at time t and HT is the hidden state of RNN at time t. Mixture density network layer, as shown here, approximates the future zt plus 1 vector with a mixture of Gaussian distributions, whose coefficients, means, and covariance are determined by outputs of R and N. And tau is a temperature parameter to control the model uncertainty. The C controller determines how to take actions to maximize the expected cumulative reward of the agent during a rollout of the environment. A single linear layer C maps ZT and HT directly into action AT at each time step, as shown here. Where WC and BC are weight matrix and bias vector, respectively. And this is a concatenation of ZT and HT. Here is the interactions of V model, M model, and the C controller with the environment. The training procedure of the world model includes first collect the training trajectories using a random policy, and then train VAE to encode frames into Z. Then train MDNRNN to model the conditional probability P, and then define C as a linear layer. Finally, solve for WC and BC to maximize the expected cumulative reward. For more details, please check with these references. Thank you.